Okay.
Yeah. So I think we should start. It's already 4 minutes.
Yeah, I think whoever comes can just join soon.
Yeah. Okay. So I'll start with sharing the page. I made sort of called progress in the sense that I put things together that we talked. So you see you see it. I also figured out that you can remove the toggle. I mean the top bars and all that, reducing. I mean giving a lot more space for us to see because you see more of the screen. Though you see this left there is this table of contents. But that comes from some extensions that are there in anyway.
Okay, that's good. So anyway, Harish has joined. So hi again.
Hi sir.
Yeah. So I mean, I just wanted to say that now that we've started, that this will be the last session for this year. So I'll be taking like 2 weeks break, and the next one will be in January. I think January 7th should be.
So it's January what date would it be?
I think Thursday is January 7th, I think. Yeah, 7th.
Okay.
So I won't be updating the calendar, so don't worry. It's just that I will update in January because there's no way to take a break. You have to only, so it'll be like on January 4th, I will add 3 more weeks. But.
Okay.
Yes. On that day, maybe I will travel to Europe.
Okay, fine. I see, okay. Okay, let's see, okay. Good, then everything's over? Visa's over?
Yes, sir.
Very good.
Packing everything.
Very nice.
Okay. Good.
Okay, so let's keep going. Good.
Okay. So we had discussed about this competition. So I'm just quickly summarizing what do we have. We're going to predict the sales data for a 2 or 4 weeks period. I don't exactly know. I am writing 2 weeks, but I see that they're probably 4 weeks. And then we have more than 5 years of sales data spread over 3 states and 10 Walmart stores and all that. And okay, second. Okay, so and then we have 3 different files. A calendar file which contains the dates and associated events. Sales data which contains the sales of how much each item was sold, where and when.
I think we should progress. I think we should go to that last part where we left off with those 3 data frames. I think that is where we were. Remember?
Yeah. So I actually redid everything in fact.
Oh, okay.
So I will, because that's why I'm doing it, because I read it because we had discussed a few things. So I did manipulate the data frames based on what we discussed. So I'll just show that so that we can continue from there instead of doing those things, because those things perhaps are not difficult to do. So I will just quickly go through it. So what is the idea? Where do we start? We take a single store in California and perform the analysis to understand the process, data manipulation, etc. That's the first thing that we do. So we got 3 data sets, and so each of them we'll have a look at. We did some basic analysis. So we have these things I have just written for my own references. But what we had done was we saw that the events, there was some form of a mapping that were going on between events and event type. So what we did was we applied an event encoding to ensure that we get a single integer element which says whether an event was there on that day or not. So there is another thing that we perhaps can do, but maybe not now, is that the events are in actually 4 broad categories: cultural, religious, sporting, and national. So it might actually help us to perhaps focus on, say, for instance, the category of products people buy based on which type of vacation it was. Like for instance, national events would typically mean people go for a vacation somewhere, or sporting might mean people would buy a lot of junk food or whatever so that they sit and watch the sports. So like that, religious and cultural might mean people buy a lot of gifts, which means hobbies might be a lot used. So we can perhaps be able to do the analysis. I haven't done anything because there are also some which contained a mix. So I didn't know how to do this. I mean, I wasn't really doing sufficient time spent on deciding how do we encode this. Because if there is a mix of cultural events, perhaps we can use 1, 2, and things like that. I mean, I had not done this, but at least what we know is that there are 4 types of categories of the events, not just the presence of events. I think that's more useful than what event it is. So perhaps we can look at this at maybe later, because this is something we can always include.
Yeah.
And then, I dropped the events and event types and the Snap, Texas, Wisconsin, and month, year. All of this has been dropped, and the calendar left out for California comes out something like this. Of course, the other thing is we need to also perhaps encode this into a date instead of a string. So I did that also. What I did was I used the date time to encode. So encode date time, where it will return the date time object, which will pick up this as the year, this as the month, and this as the date, which I do it by splitting that string, feeding them as integer converted values. Okay. So I applied it here, and you have a date time object here. Now we have, I mean, it looks the same, but it's a date time object.
Okay. Yeah.
And I dropped the date column.
Okay.
So I think these things we already discussed, and I also added one more column, or rather changed the day column from D_1, D_2 to just use 1, 2, 3, 4. So you have the day column, which is just 1, 2, 3, 4 up to I think 600 and something. Sorry, not 600. It's about 1,400 something.
Okay.
So this, and then because the training data, that is sale prices, are given only to the first 1941 days and not the entire number of days that are there in the calendar. So I dropped the last 28 days. So you have minus 28. Essentially, I'm just going to consider only the last but 28. I mean, last 28 days will be dropped.
Okay.
So these are what I did as in the calendar analysis, which I think these things we had discussed. Though what I'll do is I will send this at the end of the session. I'll send this file on the Google Groups so that in case there is a need to analyze, it will be doable.
Mm-hmm. Okay, sure.
So, yeah. So the next one is the sales data analysis. And in this, again, the first step was to only pick up all those store IDs with California 1. And because once we choose only this, we can drop the state ID and store ID. We get something like this. Now, I mean, this is where I'm now trying to figure out what to do. So what I did was I also dropped this ID, because ID is essentially putting together item ID and then which evaluation, etc. So I dropped all of that. This is what we have. Now, I wanted to do something to ensure that this can be encoded. So, of course, the first thing I did was I changed this category, category ID, which is hobbies, and there are 3 categories: hobbies, households, and foods. Mm-hmm. So I changed it into a categorical data. So categorical data, earlier it was just an object. Now I changed it into a categorical data. We still have the same, you have hobbies and foods, etc. But we can now get the codes for categories, where you see that the encoding has been done as follows. This is pandas, which does it on its own.
Mm-hmm.
You have 1, 2, 0, 0, 1, 2, whatever. This 0 is foods, hobbies, and households, because I just put it because in case we decide not to keep the category ID and instead only keep the codes, we may want to do this for inversion.
Mm-hmm.
And then there is a department ID. Again, it's not many. Like you have 2 hobbies department, 2 households department, and 3 foods department. So I haven't done anything exactly with the department ID because, but I just picked out. I just found a way to pick out this. Similarly, I will have to show you. So I'll show there. I created a temporary data frame where you have the item ID, department ID, and category ID. Now, how does this go? So here you have category IDs based on which we saw that it's 0, 1, 2. That is, hobbies is 1, foods is 0, and households is 2. Department ID is just this number. You have the last, after underscore what we have. Similarly, item ID is after this last underscore what we have. Because this one is actually the department ID here. And hobbies is what we have here. So we can as well do some actual encoding. And I also tried that. So we have this temporary. What I did was I saw that the maximum item ID that can go is about 827, which is less than 1000. So I created a unique ID, which is just a way to try and keep a single number for a given ID. We don't need so many different IDs. Though I realize that now maybe I'm wrong because we need to keep the category ID important because or perhaps even department ID. Category ID is important because you know to know whether it's a hobby one or something else. I just said, okay, category ID is multiplied by 10,000, department ID is multiplied by 1,000, and just add the temporary item ID. So you get a unique ID, and you can get back the unique ID. Each category IDs through some same manipulation, but in a reverse way. So I just verified it works, but then I haven't yet decided how to use it. But what I just wanted to show is that we can just create a unique ID for each of the items, from which we will be able to get the categories or the item ID or the department ID. So we can essentially do that. My interest will be only in the category ID because that is what is useful for us. But that is fine. So this is what I have done in sales data. So sales data, essentially, we have come down to having this, and perhaps each of these 3 have been coded into numbers and perhaps put them all together in a single ID. I probably have to change this like what we did for calendar, because this is the score 1. We can remove just put 1, 2, 3, 4. But yeah, we can talk about that, what all we can do. And the other thing is the selling data. Selling data is something I just started doing, I guess I would say. But again, in selling data, we don't have to do much. You just have to drop. You only pick up the specific amount of those sell prices data, which are only for California 1, and then you drop the store ID, and that's it. So now we'll have to decide how, like you see that here it's only item ID, because the item ID contains everything. This is the actual item, this is the department ID, and this is the category. So we have all 3 within the item ID itself. So we don't have to, that's why we probably don't need in case of, for instance, here we have department categories. These are not required because the item ID contains everything.
Okay. So first and foremost, what I would suggest is, when these kind of IDs and things like that are given, unless you really feel the need to change them, it is best usually not to change them. For example, what usually happens is with pandas and other things, it is best to use inbuilt methods of grouping and things like that, and those kind of things to actually be able to sort it out, rather than trying to actually, because what will happen actually now, since our data is not that big, it is not really that much of a problem. But when you start dealing with gigabytes of data, right, which is like literally hundreds of millions of kind of data, then if you start unnecessarily creating newer and newer categories, that's going to be a huge burden on the memory of the system. So usually, unless there is a real need, it is best to leave it as it is. Number two, the other problem is when you try to encode, if you're assuming here that all of this will have the same, that is, hobbies will always be there as it is. Now, if for some reason there is one or two something, there are some outliers, then in this kind of encoding, you will lose those. So there could be potential loss of information when you start breaking them up into specific categories and splitting them up and things like that. So unless there is a need later, I would say usually let them be. Usually.
Okay. But I think the categorical change of the categories of it was not a big deal because there was no NANs there. But yeah, I mean, however, there is no need because we have this item ID. An item ID contains all the information.
Yeah. Now, even in category ID, for example, if you want to know within a category ID, we can just do a group by within that column, right?
Yeah.
So essentially, you will know within a particular category how things are going.
Yes.
So usually, this is just it, that unless there is a real need, it is best not to completely scrub things. Unless there is. Of course, later on, if you want to put this into of course, the advantage is, if you want to put this into a machine learning algorithm and things like that, it is sometimes would be useful if you want to put like linear regression or something like that. You can give them numbers, right? So it goes both ways. There is an advantage. There is sometimes no need also.
Yeah.
Okay. So now coming to the next thing you are talking about is, we would now, if you go to that actual sales data, that is sales of each item, right? So here, if you look, this is pretty much our master data. So if you look, it contains each item, contains department, category, and it contains how many items were sold on each date, right?
Yeah.
So now the next thing what we have to do is, we have to now convert this, or rather we can take this data frame and change this data frame to another data frame which has not just the number of items sold but also the price that was actually achieved, right? So for example, if you look at the very first, the 0th column, hobbies 1001, we know that day 1932 2 items were sold, 1933 4 items were sold, right? But now the question is, how much money was actually made? That we don't know. Yeah. So now what we're going to do is, we have to now do a column join. So for example, now if you go down to the next one, there are two columns, there are two ones. If you look the next two, not the other two data frames, one is the calendar data frame.
Yeah. So I'll now okay. So we'll right now what we have. Do you see it, or I'll just do a?
Yeah, I see it. Okay. Oh, you can add.
I'm just. Do you know what is the command? Keyboard command for adding more cell?
No, I don't. Edit. I usually just go to edit and say add a cell.
Yeah, I know. I'm just.
Oh no, it's actually cell probably. It's in cell, I think. Yeah, cell.
No, but
insert.
Anyway,
inserts.
View it and then see.
No, insert. If you look at insert, it comes here. Insert cell above. So Shift A, I think.
A or B. Okay, great. Okay. I will, because that way I don't need to keep the bar on.
Okay.
So I will stay on it. So yeah. Okay. So so what do we have now? We have this.
So
Okay,
now-
maybe I'll probably add this D_1, D_2 also if you require.
No, that's okay. For now, we can work with it. So now
Yeah.
let's look at the other one. That is the price one. Sale. I think it's sale. Yeah.
Now, the selling prices is what we have after that.
Yeah. So this
And
one.
then you have,
So now, first and foremost, what we can do like this. See, for example, if you look at this, we have the item ID. Okay. We have the week, year. I don't know how you call it. WM, YR, WK. We
yeah,
have the sell price. So this tells us for that particular week how much it was the sell price, right?
yeah.
Now, so typically what this tells us is that a supermarket doesn't change the price unless it is by week, right? Because they have only said it by week. I'm surprised. I thought they would also drop it for according to special occasions, but at least they haven't given that information here. So what we have to now do is we have to now merge these two data frames. For example, what that means is, for example, if let's say we bring in the day information of the second column into this, right? So let's say, for example, let's say out of the first, that is California DFCA1, we pick out only two columns, that is WM, YR, WK, and we pick out the day. So which is it? 1, 2, 3, 4, right? If you want, just pick out the DT also, because that's a useful thing. Okay. So now if you take these three columns and we join it with the sell prices, and the joining is done on WM, YR, WK, we will now get a merged thing. So you can create another.
Okay.
So we can do it step by step. That's okay.
The only question is, when you say merge, okay, I don't know how it is. We can check what merge is.
Yeah, no, I just wanted to tell you first, but first we'll do it gradually. So first thing, let's pick out, let's say 3 columns from Cal DFCA1. So again,
so
a list.
Day?
No, within that again a list.
Yeah. No, first I want to do it and then I'll put it. Because that way it will come. Okay, anyway, fine.
Okay, that's a good idea.
Okay, so then WM, YR, WK, and then DT, perhaps. Right?
Yeah.
Because I think DT is also not required. DT, we know it. The moment we know the day, we know the DT for now.
Okay, that's okay. It's just that I just thought since you've extracted it anyway, we can have it. So, but anyway, we don't need to.
Yeah.
Because
So,
what I would
because
think, what I would say, the reason why I would say we join it is that if later you want to play around with calendar days, that's a useful thing. That's what I'm saying. And it's one column extra.
Yeah. I see. So for that, I would say that we will need W day, snap, and events also. So because if we want to do any sort of regression, any sort of analysis, we need all of them. The only things that are, the things that are left out in calendar are those we need to analyze the sales trend.
Okay, so fine, that's okay. Okay, so let's.
So that's why perhaps the merging we'll probably do with everything.
Okay, whichever. So anyway, we can start this, we can do that later, we can just repeat the process. So anyway, so now that we have this, supposing we want to merge both of them together. Now what that means is, let us now create, for this, what I would say is, take that sell prices DFCA1, take that, write that data frame, and then do dot join.
Dot join?
Yeah. So now when you open the parenthesis and do shift tab, it will tell you the help. So if you come down.
Just a second. I will make it more.
So the join is when you want to join two tables, right? So you see here the first one, the other. The other is the other table with which you want to join it with. Okay?
Yeah.
On is which column do you want to take as the common column, right? In our case, the common column is that WM, YR, WK, right? Because that is there on this one and that is there on the other one, right?
Yeah.
Then the next question, how do you want to do it? You want to do it with left, or there is right, or there is other. So you can scroll down for that a little. If you just scroll down, it will tell you. Now a left join means that it takes the left data frame, no problem, just you can scroll, there's no problem. Takes the left data frame, that is cell prices DFCA1, as the base. Okay, and the other one, it looks for all those which are common, and it adds elements to it, right? So now joining can be a little tricky, so we'll do 2-3 examples and do it. That's okay, right? So what I would say is create one copy of the cell prices DFCA1 and then let's play around with it. So you can just say copy one or whatever.
Okay.
So now to this, let us put the join, and we'll again like just do shift tab. So you can just say the other one is cal DFCA1, this is other, and the next is on. So on you have to now specify as a string WM wire WK. So by default it's a left join. Okay. So let's run it and see what we get.
No.
But no suffix specified. Okay, just go up and
Columns
look.
overlap, but no suffix specified.
Just do a shift tab. Let me just have a look.
Oh, sorry. Oh, God. I pressed a tab.
Okay. Okay, and so join columns of another, join columns of other data frame either on index or on a key column. Okay.
So one of the questions I have here is, should the number of rows be equal?
They don't. That is what I want to show you, which is what I thought I would show you. Default
But
is
let's
left,
see.
L suffix is... No, L suffix
So we
is
can
not
also
this.
sort them. Yeah.
No, okay. Can you show me the error again? Just a minute. I'm just trying to see what is wrong. Columns overlap, but no suffix specified. Suffix. Okay, just put it. I think. Okay, I think I know.
Shiva. There's one issue. Should the columns have the same number of elements precisely?
They do not.
Same number of unique elements precisely.
That could be. Also, there is another thing is, like it says a suffix, because when there is an overlap, it just wants to know that it wants to add, because I think if you check the two columns, just look at it, the two data frames, if you just scroll up a little. See, if you see here, I'm just seeing there is item ID, you see there are two indices, okay, and other than that, I'm just seeing, is there anything common? There is nothing common, only WM, YR, WK. So what I would say, if you do a shift tab again on the join.
There is one problem that I can tell you, I can show you directly now, and you can see if that could be an issue, because I removed from the calendar all the last 28 days. It also removed 4 different weeks. So for instance, if you look at the maximum, the number of unique elements in this, in cell prices, it is 282, whereas in calendar, it is only 278. So one thing we can do, because the thing is, we don't have sales prices, sales data for the last 4 weeks. So which means, while we do have a sell prices and calendar data, so we can actually remove that part.
I don't think that is an issue, because usually what happens is, if something is not being found, then it will just show up as NAM, and then we can do typically. But what I would say is, let's first sort this problem. It is saying a suffix is not found. So if you do shift tab, let's give it a suffix. So if you just come down, you see there is a suffix, L suffix. So what I would say is put an L suffix and just put cell or put S or whatever. So just put L suffix is equal to, let's say, string S.
Use
Yeah.
from left frames overlapping column. Okay.
So there might be some overlap, so which we'll figure out.
Oh yes, okay. Maybe it might put us a different new or something like that.
Whichever. We just have to see.
Yeah.
So
it has put, okay. It's trying to...
no, but I specified WMWRYK. Why is it taking me?
So it has added this as the extra...
No, but
number.
we are specifying that you want to join it on that. I don't understand this. See, you see what I'm saying, right? We are specifying that we want to join.
Maybe Shiva, maybe it is possible that is it trying to, because you see here that in this case, so the thing is the sell prices are based on item ID. The number of item IDs it is trying to go through for each item ID, it goes through each week. Okay, so that is why you have this many number of rows. Whereas in the calendar, you have the number of rows, it's equal to the number of days that we have. Now, it is not concerned with the number of what is the item, etc. So earlier I thought that we'll have to keep them separate data frames. We can merge the calendar data frame and the sales data sets, which contains how many was sold at what day, but we will not be able to combine selling prices because selling prices is per item, which week, how much was it. So,
I don't think it should be a problem. I think this is because I know that I've done something like this. Can you do one thing? Can we come down and try to do a join using the pandas instead? Maybe this is something different. So if you come down and do pd.join, just do tab, I'm just seeing if it should come.
No, it's not there. There's no pd.join. Oh, it's strange.
Okay, I think we need this thing. What do you call it? Google.
Yeah.
So just go to Google. Let's do a pandas data frame join. Yeah. So let's see how this works.
Perhaps it is pd.dataframe.join. Perhaps.
Yeah.
Dataframe.join. Perhaps.
It is if you come down, let's have a look. Data frame.join. Data frame.join. I see other. Oh, so it is data. What we did right now, basically. It's like you're taking one. Okay. So then, okay,
but
come
there
down.
Is no pd.join.
No, that's fine. That's fine. We have some help. So let's come down. So how it works? Okay, works in pandas. So let's see, if you look, there is a data frame. If you come down, scroll down and have a look at the output. So you see here, we have these two and the result is what that is. Okay. Anyway. So you see here, this is what it does. See, this is the result. You see the result here? Those columns which are not there come as NaN, result 2.
Yeah.
This is how the join works. So where there is common overlap, it will simply add it. Where there is no common overlap, it will put those as NaN. But we have specified, and if you go up and have a look at the command, just scroll up a little. So you see join. You see what they've done? info1.join info2 set index reg number. So they have to set the index. Okay, so now we know what to do. Okay, let's go back and try it out.
Okay.
So
in this, we'll have to do a...
So we have a copy of, what do we have a copy of? We have a copy of the first one. What I would say, make a copy of the other one as well. That is cal dfca1, because we have to set index.
Okay.
Okay, and now on the other, you can now specify that CP-cal index, but then say set index and WMYRW. No, CP. Make sure it's CP because it takes a copy.
Yeah.
Set index,
index,
bracket, open parenthesis, and that column WRWK. WMYR.
Okay.
Yeah.
And then on is fine.
This is the same, should be. Let's try it out.
Like, I think the suffix is not
I
required.
think so, should not be, but try it. Okay. Yeah,
Okay.
good. Okay.
Now it's fine.
So, you see here, there are some cases and the last few are not coming, as you said, because I guess they have been removed. You see the last 4. Or is the last 4 or more? Maybe, whatever.
No, I don't know. Yeah. The last 4 are the last 4 weeks. That's true. That's correct.
So, great. So, you see here.
Set index means?
What is it?
This set index now we added, right?
See. So what it is saying is, basically what it's saying is that when you're joining one column with another column, it is saying that the column that you're using to join, at least one of them should be an index. So for example, if you look at if you go up to the previous one, that is cal dfca1.
Just Shiva, perhaps before that, Harish, so this is the index, the first column that you have is the index of the data frame.
Correct.
And so what we are doing is, if you look at our first, this one, it had a 0, 1, 2, 3, 4. This also had 0, 1, 2, 3, 4. Okay. But we are trying to merge them using this. And if we are trying to merge them using this, at least one of the two, the column with which we are merging, if I put this as the index of this, then it will be good. Like we'll just see how it looks.
I'll give you one more example. And just try that out. So try to do a join.
Yeah.
No, okay, fine, finish it off. No problem.
I mean, this will be probably help him to understand what exactly is happening.
Yeah.
So if you look at now, you see that this has become the index for this guy. Instead, if I just do it like this, it's just 0, 1, 2, 3, something like this.
Okay.
Okay.
So we are saying that will be the base instead of 0, 1, 2, 3. Then it will merge according to that particular number.
Exactly.
So I'll just give you one example. Let's say, for example, you copy 91 line to 93.
Mm-hmm.
And here, if you do a shift tab inside that, you see there is how is equal to left. That is the default. Okay. If instead we specify how is equal to outer. Okay.
What is this? Outer. Okay.
Outer. So a left join will take the left, that is the CP cell prices. It will take that as the base data frame.
Yeah.
Now remove set index in this one. So like for example, if you just remove set index and let's see if this works.
Okay. No.
Oh.
Same issue.
I'm surprised. Okay. Maybe I'll just have a look at the joining, because usually from what I remember, see, it's like this. So if you're joining two tables, typically what happens is when you have tables, like these are usually SQL tables, like SQL tables. So when you have tables, you do not mix all your data together into one table, usually. So what happens is each table has a unique column. That unique column is the key column or the index column. So, for example, if you go up, the calendar column, if you just scroll up, the calendar column, it has actually the index is 0, 1, 2, 3, but if you really look, the important index is 1, 1, 1, 0, 1, right? If you really look. Now, it is not unique because what is happening is it is the day which is unique. Right? Because you are saying that for each and every day, there is a unique date and there is a week number.
Yeah. So there are 7 days you will have for a single week. So yeah.
Exactly. But the way it is when you're joining two columns and you're joining on a particular column, right? On a particular column, here we have chosen WM, YR, WK. The join would need at least one data frame to have that specified column as the index. Otherwise, the join gets confused. Okay, joining is a little tricky for that reason. That's why it will be nice if you do 1 or 2 examples that way. So, if you look, for example, if you come and have a look, let's say, for example, if you do shift tab, just do shift tab. Let's have a look at this thing. What do you call? Yeah. Let's see if anything else is written below. Efficiently joined by index. So if you look by index, if you go up and have a look by index, just scroll down and have a look. See, join columns with other data frame, either on index or on a key column. Efficiently joined by index. Now, what is happening is we have to either specify on a particular column or we have to specify an index column, right? Now we are specifying on. So come down, if you scroll down, have a look. And you see others, on. So here you see on, it will say string list or this thing. So what is happening is you are calling a column or an index level name in the column to join the index, right? Join on the index in other. See, read the thing. Column or index level name in the caller to join on the index in the other. Do you read what that is?
Yeah.
So what that says is that it is expecting the index in the other, right, to be the same as the column name on what you are joining. So it is saying that we are specifying on, that is WM, YR, WK. This is on the caller. Okay, this is on the caller. Whatever you are specifying on. And it is expecting this column to be the index of the other, right? Otherwise, it joins index by index. Now, let's have a look. If multiple values given, the other data frame must have a multi-index, right? Now, what I would say, I just want to know, Harish, are you sure? Are you guys okay with what I'm saying?
Yes, sir.
Okay, so now I'll just show you another thing. Go to Google.
Okay.
Or DuckDuckGo, whichever. DuckDuckGo. Actually, even I've started using DuckDuckGo. So now
it's not very good when it comes to some of these things, but these things are very simple. So I haven't found a reason to use Google yet for a long time now.
Yeah.
Except in Scholar I used to use Google.
Yeah. So if you say Panda is joining data frames without index. Okay. So
without index.
I am looking. No, wait. Come down. If you look at this, look at a Stack Overflow. So if you say, check it out. So I'm trying to bind with having issues with concat. So now if you see what he is trying to do, the concat is when you actually when you merge two data frames together to form another data frame, right? So here what he is trying to do is, if you come down and have a look, let's look at the solution. Usually the best is you just scroll down the solution. You see, if this is what you would like to do, and this is what he's trying to do. So if you see here, he is trying to say a concat other than a join is when you actually just add two data frames together. It completely adds them. As opposed to a join which still does it on indices. Join is still very much based on columns and indices. So what I would say, now let's say if you go, I might have to do some research on this because I remember doing long time back. If you go back to our notebook, Jupyter notebook. So the problem is that.
So what we can do is, it is asking us to give L suffix.
No,
So,
that the problem, what that happens, right? If L suffix, then the same thing will happen as what happened before. That is, it will take that
exactly.
WM. So this won't work. So this is the best we can achieve.
Okay.
So you see what has happened is, it has taken each item, it has given each item ID for a particular week, what it was, what was the cost, right? Now, what I would say is, in this, let us run a query and check for when does hobbies 1001 occur. So basically what I'm asking is, actually you can assign this to, you can assign this,
where do you want to go?
No, you can assign this join to another data frame. So another, that is line number 91. You can just give another data frame equal to, no, I mean, you can equate this to another.
Okay, yeah, I see.
Because it's returning another data frame.
Yeah. Cal cell TF and then CA1. Okay.
So now if you check out in this, just do the head just to make sure.
So I would say we can remove, in this case, those weeks that are bigger than that number, so that all those rows are removed.
Yeah, no, but before that, what I want to do is run a query and check for when is item ID equal to hobbies 1001.
Okay. I think it'll all be zeros, I think.
So you see, it has that's what I'm trying. This is what I wanted to show you. It has 1049 rows. Look at all the weeks. You see, these are all the weeks in which they have logged the prices of hobbies 1009. And look at it. It has 149 rows which are non-zero. 149. That is approximately 3 years of data. So basically, it's like 50 weeks in a row. So it's almost, you can say, well, not, I would say it's not that much. So it's not 50 because it's by day, right? Because you see there are each day. So now the main thing what we need to do is, can we, right, if we look at all these, actually for some reason day has become a float.
Yeah.
I'm just wondering, why did day become a float? I think that is numpy. Okay, that's okay, that's not a problem. We can always cast it again, that's not a problem. Now, okay, so what we want to do is this. Let us now map this data frame, okay, with our total sales data frame. Okay, so what I want to do is this. Let's take, if you go, can you just show me the head of that data frame? The cell, of all the sales.
Yeah.
I mean, you can put the head next to this merged column.
Yeah.
Okay, so what I want to do is this. Now, can we, as an exercise, find out that for this hobbies 1001, let's just pick that out. Can we find out what will be the price that is there on all these? Okay, so like for example, all these days, okay, D1, whatever, all the way up to 19, whatever, right? Can we come up with another similar data frame where we specify what is the price of it on that day? You understand what I'm trying to say, right? If we can find out, for example, if we can find out for that one, or you can take any row for that matter, what was the price on that day of that item, then we can find out how much money we made out of that item. This we can now do by comparing those 2 days. Why? Because in the previous one, we have the day. Okay? We have the day. And we have each item.
I think he's...
I think can you hear me?
Yeah, you're back. back now. Yeah.
Okay, I don't know how I had disconnected, but anyway. So what I'm trying to say is this: we have in the previous one each day, right? And we have the price for that day. Now, can we put it in this other data frame? That is, can we now take this data frame? That is, for example, let's try it out. Supposing you wanted to map these two, how would you do it?
So one of the things we can do is, so we have a day. So what we perhaps have to just do is put it in the appropriate column corresponding to, say, this. Okay, so we pick up, okay, convert this into int, okay, and add a d underscore suffix, and that will be the string corresponding to which that day is, or the column is. Or my suggestion is we can even change all this to something else. So we can do something. Essentially, we have to map this and this, and then appropriately we will just have to go for this, because we have the item IDs arranged here. You go to the item ID for that day, and that day means we don't now need to worry about the week.
Exactly. No, that is why we did this, so that we can now throw away the week. Yeah.
So we can just say this is a sale price, and then multiply with how many ever was sold, and then say that this is the cost. I mean, this is the money that we earned from this product for this week.
Okay. So you want to give it a shot at creating this function.
Okay, sure. Okay. So the only thing is, there is a couple of things I think we'll have to be sure of, because I see that, for example, for this item, it actually starts only on the 897th day.
No, that's not how it is. Basically, what has happened is that could be. But what has happened is that it is arranged according to the item. So the day can be anything. Basically, that's how it is, right? So it is just that the days. Oh God. I'm back.
Okay.
I don't know what happened.
Total, I mean, this thing is very low.
I am like right next to the router. I'll have to actually sit on the router if I have to get any closer.
It's very strange, because it's now picking up. Yeah, now it's picking up. Oh yeah, but it's still not super good. But anyway.
Okay. Anyway, yeah. So what I would say is that, okay, where were we? I just forgot. Yeah, I would say that is not really much of an issue. That is okay. If, for example, if there was a day in which we don't know the price, then in that case, we can think about that later. For example, that is missing data. So for example, it's like this. If a data is missing for a particular day, like you say that it starts at 897, the question is, what should we do? One possibility is that the item was not at all available, right? So it started being sold from day 8.
That's very likely the case.
Exactly.
That's very likely.
If we believe, yeah.
I don't know whether it's going to be correct or not, but can we melt now this sales data we have, right? Day 1, day 2, day 3, where in 98 line, output of 98.
Yeah.
Can we multiply? I can say that we can take this sale price directly and we can multiply with that number so that we can get the price.
The problem with that is that the days are becoming columns. If you come down, the next one, here each day is a column.
Yeah.
That makes it a little complicated, because what they have done is, for a column they have just put how many times it was sold. So we have to write a function. So for example, we can just start writing function. Just if there any other doubt about what I'm trying to say, we can write.
What I did was, one of the things we can do, and this is what I did in some other attempt before, to transpose this data frame, and then you can, the index will become days, so it will become a day wise. The rows will become days. So I'll just show you
Okay,
what
try
I
it out.
did there.
Sure.
So what I did was, I think there is something called transpose. Yeah. So if I do that, so you get, okay, I think there is some, I have to do something like, okay, right now it has become like this. The item ID are here, and so the day IDs are like this. So we can kind of remove this department ID and category IDs, and then put the columns as the item ID. Somehow we'll have to. So what I'll do is, for instance, here first I'll set the index as, so for instance, I will do a set index of this using item ID. And then if I do a transpose, what will happen is you get something like this. We can remove, in fact, the two.
Yeah, you can remove 2 rows, no problem.
Yeah. So what will essentially happen is, sorry, not columns.
It'll be.
You can't drop it. But anyway, we could have dropped first before we send it. Yeah, I'll do a drop here. Columns and department ID. And then category ID. Just to give this.
You need to close the list here.
And then set index for that is this will be, yeah. So you get something like this. So now the number of rows we have is the number of days, and we can actually bring this item and change the name of these. When we can create a new row, column with 1, 2, 3, 4, 5. Until 1941, and then we can put them together. So right now, what we have is we just need to go to that particular day. And then we should be able to access how many was sold for that particular item, which is on the column section.
Yeah. You can do whichever it is, it's still the same. You'll have to write a function, I think.
Yeah, definitely.
Yeah. However, whether you like it this way or the other way is the same thing.
I don't know, because the other way, what exactly do you want to do?
Oh no, it's like this. See, for example, you want to find out, let's say we take sales DF CA1 as our base, right? So you pick out item ID, right? Now, we have to now loop through each and every column, right? We are looping through all the columns. Now, in this case, what we are looking for is, when we look at a column, we are saying which of the columns has this D, right? D1, D2, and so on and so forth. Those columns we are going to extract the actual number, compare it with the day in the other one, and that to say that it is the same day in the item ID, and pick out the price.
Okay.
Both ways, either the other way or it's just one way or the other. You're looking through either columns or rows.
Okay, yeah. We'll do whichever works, whichever will be good. So now I realize, just a quick remark. I think the reason why this became float is because it introduced NaN.
Yeah, it's because NumPy. It's NumPy standard. When you go into any NumPy number, it goes to automatically NaN.
Yeah. No, that is fine. But because I think NaNs are floats, so it converted the entire column into a float.
Okay.
Anyway, because otherwise there was no reason for it to change the column type, because it didn't do anything here. So this is again a number, but it didn't change anything here. But he changed only here. That's because it's not able to. It has to NaN is because it's giving an NaN to one of the rows, and it is making it as the entire row column as an NaN. So we'll probably have to get rid of it. What I'll do is I'll correct such that there won't be any of these NaNs, because we'll remove all the columns that are above a certain, all the weeks, because there's no need to deal with it now. Anyway.
Yeah, that's okay. That's okay. Okay.
Okay.
So,
yeah.
Now, okay, we are almost out of time, but we can just get started with it and then we can leave maybe. That's okay.
Yeah.
So what we can do, we can just start the function, so like diff, whatever.
Merge sales and sell.
Yeah.
Sell price. Okay.
So this X will be a set of columns, right? It's not just one, but it's like, this is the entire data frame. We'll have to specify with axis equal to 1. So let us suppose, which one do you prefer? You want to prefer the transpose, or you prefer the other one?
No, we'll start with the straightforward one that you suggested, and then we'll see this transpose one. I will try that transpose one separately.
Okay, fine. So if you go to the previous one and see, we will be applying it on that. Okay, so we will be applying our, what do you call?
Yes, you mean?
Yeah. So we can apply. Okay, now let's see what we're going to do. We have item ID, right? And we have day.
Yeah.
Now, in the other case, we have item ID and several days.
Yes.
Right? So, what we have to do, we need to convert the other one, that is this, the one sales data, we have to include the price. So, we have to apply it on the sales DFCA1. So, what it means is, we will have the item ID and we will have several days. So, all these, we have all the columns. So, what we can do is, the first thing we can do, when we are applying, we can drop the department ID and the category ID, because we don't need that. Right? We only need the days, because in the merging, we don't need the others. We can then join it with, we can then join them together. That's not a problem. Okay?
Yeah.
So, what I would say is this. So, let's say we are applying. So, if you come down, what we have to say is, now, first we have to say what is X, right? X is a particular, X is the columns. Within X, we have to specify all the numbers, right? So, what that means is, here we will have something called X.column. So, what I would say is, if you look, okay, you can write the comment or whatever.
Yeah, you go on.
So, first what you can do, bit by bit, you can just say print X.columns.
Yeah.
And if you come down, no, it's not this thing, it's not a function, it's an attribute. That what? Is X, columns is just an attribute, so there's no parenthesis.
Yeah, okay.
So, if you just enter, and if let us run it.
On which one?
On this sales data, that is.
No, sell prices.
Is the other way. Is the other way. You have to say sales prices dot apply. Merge.
Okay. You want to apply, yeah. Okay.
Yeah.
So I think this is a CP one, right?
Yeah, whichever, I don't remember. Dot apply. And then you have to specify this, and then axis is equal to 1. And axis is equal to 1, because remember, you're passing the data frame.
No. Series, it says it's a series.
Okay. So now what it means is, it is passing through every row, and it is giving you a particular, what do you call it? It is giving data. So what do you say? X.data. Supposing you say print X.data.
This one?
Yeah. And okay. Try it again, the other one.
Series
that is merged.
Doesn't have any. So here we have to remove axis one?
I'm surprised. No, it should not be. Okay, just one, right? No. Okay, so what? Okay, now this is getting a little tricky. Let me just see. Okay, so what this means, you know what this shows, right? See, what this shows is that we cannot access automatically. It is taking each row as a series, right?
Okay.
And so let us do index, x.index. Because I'm just first trying to do how we loop through the index. So now we have, no, that should not be the case. Are you doing the right one? Can you go?
You want the sell prices, right? What
I want that long column with all the days and everything. This one. Sales. I want sales.
Sales, this one?
Okay. Sales DF, yeah.
Okay, I think I have to stop. This is going on and on. I don't know how long.
No, just do run. Just do run dot this thing. Run, stop that. Kernel. So, no, interrupt.
Interrupt. Okay. Yeah.
Yeah. So now.
So I will.
Okay. So now we don't need any more.
So I need to clear the current outputs now, because current outputs I'll clear, because otherwise what happens is it takes.
Okay, no, then we don't need this.
A lot of space.
Yeah, we don't need this anymore. So that's okay. We know that we can get the index, right? Yeah. So in the index, when you loop through, so that means.
So this is what you want to do now.
Yeah. Only thing is you can remove the print statement.
Okay.
We have the x index. So in the x index, what we have to say is, we have to say for column in x index. So we are looping through all the columns. Don't use column, use something like calls or something else, because that could be a reserved word. So these are all the columns, right? Now what we have to see is, we have to see if it is in the format of D dash, right?
Yeah.
So what we are going to do, you are going to say split of D dash. So if you come down, you just go to some other column below and let us try it. Come down. Yeah. Take the string D, let's say A is equal to D25. Now we cannot use simply underscore, use D underscore.
Okay.
So you see what is happening, right? If you use D underscore, then in that case, the first one will be an empty, a blank string, and the second one will be the number. Okay?
Yeah.
Now, supposing you replace this with item ID and see what you get. What I want to make sure is, see, basically we have.
What do you mean item ID?
No, the reason.
This one?
Yeah. No, not this. The actual column. So if you go up, what happens? If you just scroll up, and tell you why. We are taking all the columns. Right? Some columns will not be in this D underscore. For example, if you go up, you see there is depart. Yeah. Okay. So take cat ID. Supposing you say cat ID.
Yeah.
If you say that, if you come down and just say cat, that is, replace D underscore 25 with cat ID. No, not that one. Not that one. The first one. Yeah. And then, yeah.
Sorry.
Yeah. So you see here, if D underscore does not come, then you are getting a single element.
Yeah.
And when you get a single element, that means that is not a date column. So this is our what do you call it? Our condition to know whether this is a date column or not. So if you say,
okay, I see.
All right, get what I'm trying to do.
Yeah, I see. So to ensure that we are in the date column, you are going to date column. We are going to see this and see if the length of it, for instance,
is greater than 1.
Equal to 2.
Yeah.
Then we do something. We do the work.
Yeah, exactly. And then what you have to do, the second column, or that the index number 1, is the actual day, and that if you do an integer of it, that is our day. So you can say day is equal to str.split and take the first element. That is the.
I think what we'll do is I'll just do it once, because
exactly that is also better.
The num or something like that.
Yep.
And the end. And then I'll put it here, and then I will do.
You can say day
of 1.
Yeah. Okay.
integer of that.
Yes. So now this is the actual day, right?
Yes.
Now, this day, we are now going to check what is the item ID, right? That is x dot x of item ID and this integer in the other data frame.
Yeah.
Okay. Okay. So we have extracted out of for this, if you just scroll up a little. So this when you apply it, or no, a little down again, sorry, go to sales DFCA. Yeah. When you apply this function on sales DFCA, it goes through each and every row. Okay.
Yeah.
Now, for a particular row, you can extract the item ID, and using this logic, you can extract the day number, right?
Yeah.
Now, we now use this to go up to the previous data frame, and there we run a query on that data frame. So what we are going to say is, we are going to say that for this item ID, if this item ID, that is for the other data frame, if you scroll up a little, in this data frame, if we say that for this item ID is equal to the same as this one, and the day is equal to the same as this one, integer, then find out the price and multiply that price with the actual value of the day. Okay?
Okay. Okay.
I mean, this is one way. I'm not sure if this is the best way, but let's think about it. Maybe there's a better way.
Yeah. We have 3 weeks. Okay. Yeah.
Anyways.
Okay.
Yeah. So anyway, I hope it is okay, Harish.
Yeah, sir. Yeah. This is 2 means integer, right? We are finding for the 2 integer. Sorry.
Yeah. It's basically what we are trying to do is, we are trying to find out if that particular column is a day column or is any other column.
Yeah.
So if it is a day column, that we are extracting the actual day number and we are going and looking for the corresponding day number in the other data frame.
Okay.
What would be interesting is if we can do a join of these two, but I see that as a bit tricky from what I see, because they are two very different data frames, very different.
Yeah, in fact, no, I did actually merge the sales data and calendar. I already did that once. So I think that is possible. I was thinking this one is difficult, merging sale prices and calendar, but we already did that.
Okay.
So this one should not be, the way you do this is very simple. You as I did, I essentially did what I did here. So first you merge the calendar and the sales by using the day column, because you have 1941 rows here, and in the calendar you have 1941 rows. So you can easily merge. There are these. You will end up having 3049 columns, and when perhaps what you then do is you then transpose it, where you will get now the number of the columns will be the same as these number of items, which is actually what we have here in the sell prices. So you will be repeating that sell prices and we will actually get it. I think we can combine it. I'll try it.
Yeah, actually, like you're saying, it's also possible. What you have to do is you have to insert a column of the week, WM wire WK, right?
Yeah.
Once you insert the week of that, you can insert the price as well.
Yeah.
The only problem is, what I see is, you will have prices for each and every item. That is the problem. So you will actually have to split it up as a sub-column. So here, for example, you have hobbies 1001. For hobbies 101, there will be two columns. One is the number of prices, number of items sold. The other is the price for that particular day. Then you can multiply them and get a third sub-column.
Yeah, I know. You are right. Yeah, that's why it's difficult to merge, because it's for the same column. Yeah. It's a different number. Yeah.
I mean, it is an exercise, but I would say that sometimes maybe it is easier to write a function.
Yeah. Okay. Yeah.
So anyway, guys, it was a long one, but it was good, and we will be meeting after 3 weeks. So anyway,
We'll see.
so
Okay,
yeah,
then.
Happy New Year,
See
everyone.
you. Yeah. Happy New Year, Harish. Happy journey also.
Yeah, happy journey, Harish. See you in Europe soon. So then we all three
Yeah.
will be in the same place, more or less, time zone.
Yeah. Okay. That's good. Okay.
Okay then. Goodbye, everyone. See you in 2021.